these are the three methods we learned yesterday, just practicing one from each. Number one, it's written in log form, so we need to change it into exponential form, and we just have one log, so we can switch that immediately. The base, since there's none listed there, we know that it's a 10. Exponent's the 3, and that's equal to 2x plus 4. Well, 10 to the third, you should have gotten 1,000. Solve for x. Subtract 4. So you have 996 is equal to 2x. Divide 996 by 2. And x should have equaled 498. We're going to go ahead and check that one. So for the check, log 2 times 498 plus 4 is equal to 3. Well, 2 times 498 would be 9996. Add 4 to that. So we're looking at log of 1,000. Now keep in mind that's a base 10, so you can just type that into your calculator. So when you typed in your log 1,000, you should have gotten 3. So 3 equals 3, which means this is an actual answer. Going over to number 2, before we can do that, we need to put those logs together since they're on the same side. We can't cancel them out. We'll look at that in number 3. So since it's being added, I know I can multiply the logs together. So we have log of 10 times 2x. So that becomes log of 20x equals 3. So same thing, has a base of 10 since there's not one listed. So 10 cubed equals 20x. Divide both sides by 20. And I'm doing that because we already knew that 10 cubed was 1,000. So 1,000 divided by 20 is 50. Let's go ahead and check that. So I have log 10 plus log of 2 times 50. I want it to equal 3. Well, log 10 and the log of that's going to turn into 100. You can type into your calculator. 10 log of 10 is 1. Log of 100 is 2. And 1 plus 2 does equal 3. So that is an actual answer. Number 3, this is the one where since the logs are on opposite sides and have the same base, we can cross them out. And we're left with their arguments, which is 7x plus 1 equals x minus 2. So we're going to subtract x. So I have 6x plus 1 is equal to negative 2. Subtract 1. 6x equals negative 3. Divide both sides by 6. So x equals negative 1/2 or 0.5. And there are your 3 answers for the warm-up. Going over your homework answers, you can see 54 through 61. 54, 55, and 56 are like the first one in the warm-up. 56 has that negative 2 on the outside that you have to get rid of. 59, 60 are like the third one in the warm-up, and then 61 is kind of a combination of 2 and 3. With 61, the logs on the same side have to be combined before you can cross them out. Pause if you need to see more of the work. Here are your last ones. 57 was like number 2, 58 was like number 2, and 62 was like a combination of 2 and 3. So go ahead, check through these for the answers. You'll notice on 58, when I got 6 to the first, or just 6 equals 5 over x minus 7, I set this up as a proportion, so I put the 6 as a fraction over 1, and then I cross multiplied in order to solve for x. Four 6 is what we're going to be looking at today, so go ahead and get your notes ready. You'll notice there's a little bit more on the top of it that you need to write, so I'm going to pause this, or you're going to pause this so you can write what you see up there on your notes. And this is the letter E, which we've seen before, and this is ln. I know that's a little sloppy. So make sure everyone has this written before it changes. Log E is what we call a special kind of log. And remember, E was that number in your calculator that we used when we found out what e to the 1 was. It was 2.718, and it continued. So we used the letter E. Well, since it's a special log, we call it ln, which is a natural log. So now you need to make sure you take a second and find that button on your calculator. It should be the button that has an E right above it, an E to the X. So find ln, because you're going to be using that button today. And what you need to know is E and ln are inverses of each other, which means they would undo each other. So just like logs and exponential forms kind of undo themselves, which is why we use them when solving equations, if we see an ln, then that means we need to insert an E, or if we see the E, we need to insert the ln. So our first problem says e to the 2x equals 5. Well, since there's an E in the problem, I need to insert in ln. So we're going to go ln of e to the 2x, and what I do to one side I have to do to the other. Well, the ln and the e cancel once they're side by side. So those are gone, and that just leaves me with 2x is equal to ln of 5. Well, to solve for x, we're going to divide by 2. So when you type this into your calculator, you remember there's 2 ways to type in. Some of you simply type in ln and then the 5, just like you would have typed in log in a number, and some of you have to do it backwards, 5 and ln. So let's make sure we get the right number. So the natural log of 5 should be approximately 1.609, and it continues. So once you get that, you know how to type it into your calculator. Now we need to divide that by 2, so in your calculator, go divide by 2. And we're going to go ahead and round it to the hundredths. No, the 10,000ths, that's where we've been going. So 0.8047. On your paper, you should see your u-try, which says e to the 3x minus 1 equals 10. So go ahead and solve that problem. Ignore the u-try that you see on the screen. Look at the one on your paper. So pause this and then unpause it when you're ready to check your answer. So again, since there was an e, we're going to insert the ln. And you have to insert it to both sides. The ln and the e cancel. So you had 3x minus 1 equals the natural log of 10. Remember, you are just going to keep that number into your calculator. So we'll write the approximates, but just don't cancel it in your calculator. So the natural log of 10 was 2.302 and 6 because that 5 rounds up. So then we would add 1. So then I have 3x equals, and again, make sure you type that directly into your calculator as well. Even though I know you can also do the work, but we want to keep the exact answer in the calculator. And then divide by 3. So you should have 1.1009 because the 8 rounds up since there's a 6 over. All right, let's move on to our next problems. So again, I know my slide is a little bit different, but that's okay. We'll come back to that 5x plus 5 equals 2. If you look at the top of your screen, you're going to see ln 7x equals 6. We're going to do this problem. Now, this time it starts with an ln. Well, the inverse of an ln is an e. So this time we're going to insert an e to the ln 7x, and that 6 also becomes an exponent because e is always raised to something. So here the e and the ln cancel, which leaves us with 7x equals e to the 6. So now in your calculator we're going to figure out what e to the 6 is. So we have 7x is equal to approximately 403.4288 because that 7 is going to round up with the 9 behind it. We're now going to divide this by 7. And again, make sure you kept it in your calculator and just hit divide by 7. So x is approximately 57.6327. That 6 rounds up because of the 8. So go ahead and try the u-try on the right. So since there was an ln, we should have inserted an e to both sides. E and the ln cancels, which drops this to a 5x plus 5. E squared is 7.389, and then 1, that 0 should have rounded up because of the 5 behind it. We're now going to subtract 5. So I have 5x equals 2.3891. Make sure you also do that in your calculator. And then we divide by 5. So x is approximately 0.4778. This time it didn't round up because there was a 1 behind it. So again, e's and ln's are inverses. So if you see 1 in the problem for an equation, it means you're going to insert the other one. Now, what happens if both of them are already in the problem? Well, what happens with an ln and an e? They cancel. So in this case, the ln and the e simply cancel, and we're left with 10. So when they're both in the problem, the number that's there is what you're left with. So go ahead and quickly do the u-try. All right, everybody should have an answer. We cross out the ln and the e, and we're left with 535. So those are the 3 types of problems you're going to be seeing tonight, and that wraps up Chapter 4.